You know the feeling, right? We've all been there. That critical piece of equipment, the one you absolutely rely on, just dies out of nowhere. It's so frustrating, costs a ton of time and money, and yeah, it always happens at the worst possible moment.
So you're left asking yourself, why? Why does this stuff, this equipment that's supposed to be dependable, just suddenly fail on us? Is it just bad luck, or is there something deeper going on? Well, what if I told you we could not only figure out why it happens, but actually get ahead of it? Turns out you can.
Here's the thing. We have to stop treating these failures like there's some unsolvable mystery. They're not. The answer is actually a clear, repeatable process, a diagnostic process. And today, we're going to walk through exactly what that looks like.
Okay, let's get into it. The whole method really comes down to these 3 simple steps. First, you've got to measure accurately. Then, you analyze what you found, kind of like a detective looking for clues. And finally, you compare what's really happening to what you expected to happen. That's it. This is our roadmap, and it's a super powerful framework. So let's break each one down.
All right, step 1. And honestly, this is the most important part of the whole thing, getting good data. I mean, think about it. If the foundation of your house is shaky, the whole thing is going to come crumbling down, right? Same deal here. If your measurements are off, any analysis you do later is basically worthless.
So this means you have to be really intentional about it. It's not about just grabbing a number here and there. You have to decide exactly where on the machine you're measuring, how you're going to do it, and when you'll take the data. That consistency is what makes it trustworthy. This is your ground truth, the solid rock you build everything else on.
So once you have that solid, reliable data, it's time for step 2. Time to put on your detective hat. The analysis part is all about figuring out the story that those numbers are trying to tell you. And to do that, you need context.
And that's the absolute key to this step. See, raw data by itself doesn't really mean a whole lot. An uptime percentage is just a number floating in space until you add some context. For example, a machine might run great on a cool day, but struggle when it's hot. Or maybe it performs differently when it's going full blast versus just idling. You've got to account for these outside forces.
We can usually boil these factors down into 3 big categories. First, load. Just how hard is the equipment actually working? Is it under a heavy strain or is it taking it easy? Second, you've got speed. How fast is it running? And third, the environment. We're talking about everything from temperature and humidity to vibration. Really, any outside condition that could mess with performance. Looking at your data through these lenses is what turns those numbers into real, actionable insights.
Okay, so you've measured everything accurately. You've analyzed it with all the right context. Now comes the moment of truth. Step 3, the verdict. This is where we take everything we've learned and hold it up against our goals to see where we really are.
And this is where the magic really happens. You put your expectation on one side, let's say it's a reliability goal of 99% uptime, and on the other side, you put reality, the actual performance data you just gathered and analyzed. And that gap you see between what you want and what you've got, that's not a failure. That is your opportunity. It's a big flashing sign pointing you right to where you need to improve.
But okay, what happens when that gap is pretty big and it's not totally obvious why? Sometimes that first look tells you that there's a problem, but it doesn't tell you why there's a problem. That's your cue to dig a little deeper and bring in some more powerful tools.
The first tool in the advanced kit is something called root cause analysis, or RCA. The whole point of RCA is to get past the symptoms, like a machine overheating, and find the real, fundamental reason it's happening. Was it a bad sensor, a vent that got blocked, or maybe a flaw in the design itself? RCA helps you find the actual source of the problem, so you can fix it for good. And another really powerful tool is called Weibull analysis. This one's a little more about looking into the future. It's a statistical method that chews on your past failure data, not just to understand what happened, but to actually predict what's going to happen. It can help you answer really important questions like, hey, based on its history, what's the chances part is going to fail in the next 1,000 hours? Pretty cool, right?
So when you put this all together, what does it really mean? Well, it means the process we just walked through isn't some one-off trick. It's a repeatable playbook. It's a system you can use to turn those frustrating equipment failures into genuine opportunities to get better.
So just remember these 3 steps. This is your go-to toolkit. Measure consistently, analyze with context, and compare against your goals. This simple, powerful process is what gets you out of that reactive, constant firefighting mode and puts you in control, making proactive, data-driven decisions about reliability.
And that really just leaves us with one final thought. You have the framework now. So, thinking about your world, your equipment, your challenges, what's the very first thing you need to start measuring tomorrow? Because that's where this whole journey really begins.